Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. On this occasion, I would like to deliver my presentation under the title Synthesis and Characterization of the Lubricity Enhancer from Palm Oil. Let me introduce myself. My name is Sofia Maswariwalidatu Saliha. This is the introduction of this research. We know that environmental degradation due to air pollution are a crucial issues that must be addressed. Creating a newer technologies by improving fuel efficiency and reduce pollution in the automotive sector is the problem solver of this case. Diesel engines are widely used for transportation. However, the effect of the emission of diesel engine are raised to environmental degradation, such as greenhouse effect and acid rain. The effect of using fossil fuels is the high sulfur content, which causes air pollution of sulfur compound, leads to releasing a dangerous oxide and cause acid rain. The alternative way to reduce the sulfur content in the fuel is through desulfurization, but this process will reduce the lubricity properties and also release other compounds such as nitrogen and oxygen-based polar substance. The most effective way in solving the lubricant problem is addition of anti-wear agent to diesel fuel. Vegetable oil can produce fatty acid methyl ester through the trans-esterification with alcohol using this catalyst. Recent work was presented by Rizende provides lubricity improver additive derivative from linoleic oils with 1.2 ethanediol using potassium carbonate as base catalyst. In this work is study about synthesis and analysis of the product from trans-esterification of palm oil with ethylene glycol using base catalyst potassium carbonate. Next, this is the methods of the result. Consists of synthesis of fatty acid methyl ester and synthesis of hydroxyethyl ester. The composition of palm oil was determined by BIS-MAS analysis, so the palm oil has to be changed to its fatty acid methyl ester, and the product from synthesis of hydroxyethyl ester was monitored by CLC analysis, and the chemical compound was determined by using BIS-MAS analysis. This is the procedure for synthesis of fatty acid methyl ester. Palm oil was heated up to 60 degrees Celsius and add some methanolic solution which made from methanol and potassium hydroxide. The reaction time was set for 2 hours and the mixture was cooled to room temperature and add to separating funnel. The organic layer was evaporated using rotary evaporator and washed with aqueous, dried with sodium sulfate, and then filtered using filter paper. And next, the procedure for synthesis of hydroxyethyl ester. Palm oil was heated up to 150 degrees Celsius and pour some ethylene glycol with a molar ratio oil to ethylene glycol is 1 to 10 and potassium carbonate about 8% mole of palm oil. The reaction time was set for 5 hours. After 5 hours, the mixture was neutralized with 10% of hydrochloric acid solution and then extracted with ethyl acetate and dried with sodium sulfate and then filtered using filter paper following by evaporated using rotary evaporator. Now this is the result and discussion of this research. The fatty acid methyl ester as a synthesis product was analyzed by BIS-MAS. Chromatogram profile from BIS-MAS analysis was shown in Figure 1. The chemical structure of each peak in chromatogram profile can be determined by analysis of its mass spectrum. The result from analysis its spectrum from each peak was presented in Table 1. According to this table, the main composition fatty acid in palm oil is oleic acid, palmitic acid, and linoleic acid. Next, this is the result from synthesis of hydroxyethyl ester. The conversion of palm oil into the product is 72.9%. The TLC analysis was needed to monitoring this product. This picture was showed the result of monitoring product synthesis by TLC analysis. The node which marked with green circle is predicted as a hydroxyethyl ester product, and the brown square was predicted as a triglyceride. According to this analysis, hydroxyethyl ester product was successfully formed because of a minimum node of triglycerides in products and also form new nodes in products. The product which have been predicted from TLC analysis was confirmed by the characterization using BIS-MAS analyzing to determine the chemical compound of the product. This characterization was based on the peak which have been given in chromatogram profile in figure 3. The mass spectrum in each peak was analyzed to determine the chemical structure of the product. In Table 2, presented the main component of hydroxyethyl ester product is the peak number 4 and number 5 as hydroxyethyl ester, and the peak number 6 and number 7 is the byproduct as ethylene glycol diester. This is the conclusion of this result. The hydroxyethyl ester compound was successfully synthesized through trans-esterification reaction between palm oil and ethylene glycol using potassium carbonate as a base catalyst. The conversion of triglycerides into the products is 72.9%, and the main composition of this product is hexadecanoic acid to hydroxyethyl ester and octadecanoic acid to hydroxyethyl ester with a byproduct as ethylene glycol diester. The authors would like to thank to Kementerian Energi dan Sumber Daya Mineral for financial support to this research, and also thank to PMAK Migas for the facilities for analysis. That's all. Thank you for your attention. See you next time. Wassalamualaikum warahmatullahi wabarakatuh.